Okay, so let's today take a look at the standard form of your sine and cosine angle functions and what the various values in a trig function would count for. So let's look at the first one. Generally, your general form goes a times the function. B is usually what's multiplied in front of the unknown angle or the x. Sometimes that's theta, and sometimes it's x. Negative c, it's always the opposite sign for the c inside the parentheses. C always occurs inside the parentheses if there are no parentheses. It's actually the D that you're seeing. It's the number that hangs out at the end. So let's see what each one of these positions do. The A is the amplitude. It's always positive. Even though if there's a negative there, the amplitude itself would be a positive. Like if it was a negative 2 there, the amplitude is just 2. Okay? And it causes a vertical stretch. It doesn't do any shifting or raising of the function. It just stretches and lowers the peaks and dips. Okay? And a negative would just flip it about the x-axis. So if the sine curve went up for a positive, it would start off going down for a negative. So it's a reflection over the midline, whatever the midline is. Okay, the B is used for the period, but the B is not the period. You have to take the B, whatever number is in front of the angle, or the coordinate there, the x coordinate. Whatever numbers in front of that are being multiplied directly to that variable, that has to go up underneath the value of 2 pi. So, and that causes a horizontal stretch or condensing almost. It's what really causes the period, basically gives you the accordion effect of how close and how far apart your dips and peaks are. So that's what I mean by a horizontal stretch. It's like the accordion effect. Okay, a phase shift, it moves the function back and forth, but the whole function moves. So the distance between the peaks and the dips aren't changing. It's not like crushing in the peaks and spreading them out like the period does. It just moves them at an equal distance, both at the same amount. So that's what the phase shift does. And of course it's opposite. So if it's a positive phase shift, it would move in the negative direction, much like what you did with what was in the parentheses for parabolas when you move those around for the vertex, if you remember that back in that topic. And then the vertical shift just moves the whole function up or down. There's no stretching. The peaks don't get any stretchier. They just move up, and the dips move up with it. So I'm going to take a look at a couple of these uses, these examples here in this one right here. So if we want to take a look at some transformations, things we need to do. And the D is also, whatever that D value is actually the value of the midline too. So a lot of times we're asking what the midline is. The midline obviously has something to do with the vertical shift going up or down. Okay, so let's see if we can't take a look at how we find these. Now, this obviously has a vertical shift up. Okay, how do I know? Well, there's no equal distance. Here's the x-axis, and on the parent function, this would be equal. The same amount up, the same amount down. So that's what put the midline of the x-axis right in the center of the graph. Well, the center of the graph is not here. This is a small amount. This is a very large amount. So these are not equal. So we're looking for that line that is. There's several ways you could do this. Okay? And why do we want the midline? Well, the amplitude is the distance between the midline and the peak. Well, this isn't the midline, so I wouldn't just go 1, 2, 3, 4, 5 and say the amplitude's 5, because that's incorrect, because this is not the midline. So I'm looking for the midline. There's a couple ways you could do this. For the most part, you could just count 1, 2, 3, 4, 5, 6. So if the whole range of the function is 6, the amplitude would be half the range, which is 3. So I would come down 1, 2, 3. And that would give me my midline, and it looks like my midline is y equals 2. That's one way to do it. Let me show you another way. Suppose you're not working off a grid and you've just got values. This would be 5, right? And this would be -1. So maybe you only have the values and you don't have the grid marks. So it might be too hard to count. Another way you could do this is subtract the max. Let's put this here, max minus the min, and then just cut that in half. So 5 minus the -1, cut in 2. So 6 divided by 2 is 3. Yeah, that'll work. So that'll work. But this is for the amplitude. So max divided by min, or subtracted min divided by 2. Okay, so that would give you 3. Now, you would also do the same thing for the midline because you need the amplitude to go ahead and count down from your pink to get your midline. So 1, 2, 3. So the y equals 2. So you could say max minus the amplitude would give you the midline. So 5 minus the amplitude, which is 3, gives you 2. So y equal 2 is your midline. So it would work that way as well. And what about the period? Again, the period is how long it takes to get from one peak to the other, or in this case, sine 1, 0 to the next 0. So we're looking for one full cycle of sine. What you really want to do is try to start at 0, so you don't have to start subtracting fractions with pi's in it. You really don't want to do that. So I'm going to start at 0 here, and here is one cycle. I'm going to highlight it in green. One cycle of sine. It's you got a dip, you got a 0, you got a peak, you got a 0, you got a dip, and you got a 0. That's one full cycle of sine. So what was the distance it took to complete that one cycle? It looks like it was pi distance. So the period is pi. Okay, so there's your answers right there. Amplitude ended up being 3, period ended up being pi, and the midline is y equal 2 equation. So hopefully that helps. I know it's a lot to take in, and obviously you wouldn't have to do all 3 of these in a question. These would be one question each. Find the amplitude, give you another one, find the period, give you another question, find the midline. So it's a lot to do, but that's like 3 questions in one. That's not like, you know, those would all be separated. So I hope that sums that up. Again, if you don't have this in your notes with some type of, if not my words to help you remember, you could put your own words in it, but you really should have something like that in the notes because, again, like I said, it's an awful lot to remember, and you need to sort of like a little bit of a cheat sheet in your notes to help you remember what to do for each type of question. So I hope that helps, and thanks for watching.